Hi, welcome to this module. This module is again continuation of your last module, and in last module we have seen how can you fabricate ETM biochip for measuring ETM properties. In this module let us see that how we can create a micro actuators or micro robots, not really micro robots, robotic arms with microchips, alright, for understanding the tissue properties. Before that we will see the how we can develop these sensors. If you see the slide, in this slide we can see that there are 3 thermistors, 1, 2 and 3, thermistor 1, thermistor 2, thermistor 3, and in the center there is a heater, alright. So, what happens is, let me first understand this, let me tell you about this chip first, now this design first. This is a trench or pit, right, pit. This one, the thicker one, are your interdigitated electrodes. Which one? This line and this line, right. If you see this one, it goes here, here and here. This line goes across it here and here, right. So, and in the center there is a heater, correct. So, now this is your chip design. How to fabricate this chip? We will see in the next slide how to fabricate this chip, and what is, why we have fabricated, how we are using it. Now, we understand that there is a tissue in the center and this chip is on the both ends. Which chip? This one. So, now if this is magnified version of or this one single chip. This is the enlarged figure of this particular single chip. So, if I attach this chip on one side of the tissue and another chip on the another side of the tissue, right, and I heat it from one side with the help of heater, I can measure the change in the temperature with the help of thermistor on another side of the tissue, and that means that I have T1 here, I have T2 here, that means I can measure the thermal conductivity, correct. Now, I have interdigitated electrodes. So, as soon as this chip touches the tissue, I can measure the impedance of the tissue. I can measure the surface impedance and I can measure the bulk impedance of the tissue, right. So, this is how the simulation can be done for the heater at least, and you can see it is almost uniform in the center of the chip, and that is a very good news, because then we can use this chip for heating the tissue uniformly. And you can also see that this is without trench, but if I have a, this is with this particular part, you see, right, and these are the interdigital electrodes and this is a heater in the center. So, there is a simulation for that, which is a heat profile of the heater, and this is the fabrication. So, we start with a wafer, which is silicon wafer, we clean it, then we grow oxide, which is a schematic B, and after growing oxide we perform lithography, and this is lift off technique. So, first is your photoresist, you have pattern your photoresist like this, which is your positive photoresist. On positive photoresist you have deposited platinum, and then you have dipped this wafer in acetone. When you dip this wafer in acetone, what will happen? You will have you have heaters, you have the heater, right. Then you can create a trench. For creating trench, you can again perform the lithography and open the window, remove silicon dioxide. Silicon dioxide can be etched with the help of BHF, buffer hydrofluoric acid. Once you remove silicon dioxide, you can etch silicon using DRI, right. So, your trench are created, and then on that you can also create your interdigitated electrodes, but here it is just showing the thermal sensors, right. So, let me go to the next section. Here you can see then optical image of the sensor, which is right over here, right. Again, like I said, thermistors, thermistors, thermistors and heater, right. This is your interdigital electrodes, and if you see this particular chip, then it can place within the like a SIM card holder, because we do not want to do soldering or wire bonding, as after one measurement you have to throw the chip, because for biological samples you cannot use the chip same chip again and again. So, you have to fabricate a chip that is cheaper in cost, as well as the holder should be easy, you can just place the chip rather than doing wire bonding and soldering. So, if you see further, you can see here that this is the actual photograph of the chip, some characterization where we can see that the alpha was calculated about 2.2 into 10 to the power minus 3 per degree centigrade. R square value was really good, and as well as the we have done some hysteresis profile, increasing temperature with decreasing temperature. Now, these are the actual systems. So, again there are 3 videos actually. This is the first video. In the video what you have seen that there are indenters, and in the indenters there are blue color thing which are indenters. At the tip of the indenter we have attached the chip that I have just shown it to you, and those chips are used for understanding the electrical and thermal properties, while the top indenter it presses tissue from the top. If you see the render image on the right side of the screen, then you can understand that there are the 2 actuators, and here is the actual photograph where there is a arm 1 versus arm 2, and at the tip of this arm you can see here that we have the chip attached for the for measuring the tissue. Alright, so I will just switch to the next section, and that is on the heart. We will talk about atrial fibrillation, but let us talk about atrial fibrillation in the next module. I just wanted to give you a very quick updates about the newer design of the chip that we are fabricating as a part of the research, and it is really important for you guys also to think a novel kind of sensor design that can be easier to fabricate and can be used for understanding the tissue properties. Now, we are talking about breast cancer, but we are not limited to breast cancer. We can use different tissue related cancer. It can be oral cancer, it can be cervical cancer, it can be prostate cancer, and wherever tissues are there we can understand how the tissue property changes, right. So, once you understand the sensor fabrication and you can design new novel sensors or new sensors, you can measure different properties. Alright. So, in my next module I will be talking more on the heart disease and how the atrial fibrillation, which is one of the important disease which causes death in patient, how it can be treated, and why sensors are very important, including actuators are very important, because we have to design a novel catheters with a maneuvering system to treat that particular disease. So, till then I will take leave from you for now, and I will see you in the next class with a more interesting problem to identify and to fill the gap, and a very interesting actuator and sensor system to find a solution in terms of medical devices, right. Till then you take care.